Hey everyone, and welcome back to Backend Decoded. Today's problem gives you a garden. Some plots already have flowers, some are empty. Your job is to figure out if you can plant n more flowers without putting two flowers next to each other. Sounds like a gardening problem, right? It's actually a greedy algorithm in disguise. Let's break it down. Before we dive in, this problem has been asked in real technical interviews at Amazon, Cisco, and LinkedIn. So if you are targeting any of these companies, pay close attention to the interview explanation section coming up. Let's get into it. Now let's make it formal. We are given an integer array flower bed containing zeros and ones, where 0 is empty and 1 is planted, and an integer n. So, and we basically need to return true if n new flowers can be planted in the flower bed without violating the no adjacent flowers rule, and false otherwise. Let's see the example. This is the flower bed containing elements like 1, 0, 0, 1, and n is equal to 1. Okay, the output is 2. For the same flower bed, if n is equal to 2, the output is false. Right? Same flower bed, n is equal to 1 works, n is equal to 2 doesn't. So no room for 2 more without violating the rule. Now here is the pattern recognition moment. Let me show you what's happening visually first. Let's say we have given this flower bed of 5 plots and an integer n. Okay, 5 plots out of which 2 plots already has flowers and 3 empty in the middle. Okay. So the question is, can we plant one more without breaking the no adjacent rule? The constraint is no two flowers side by side, right? So let's see position by position. Okay, the 0th position plot already has the plant. Okay, so in this case we simply skip. Okay, skip. Now go to the second position. The plot is empty, right? But the left neighbor is empty. This basically violating our no adjacent rule. So skip this position also. Okay, now we are at the second position. Now let's see here, the plot is empty, the left is empty, which is the first position is empty, and the right is also empty. Okay, so this is, if we plant here, then this is not, this does not violate our no adjacent rule, so let's plant it here. Okay, so let's make it 1. Now let's move on to the next position, which is 3. Now see, the plot is empty, but the left plot is having planted just by the previous operation, right? So we can't plant here, so just simply skip from this. And now let's move on to the last position, which is already planted, so skip this. Okay, so we have planted the flower at one plot in the flower bed. Okay, so n is equal to 1 and we have planted 1, so yeah, so we planted at position 2, so n drops to 0, so output should be true, right? The pattern, plant as early as possible, that's greedy. Now here is the pattern recognition moment. Let me show you exactly how I read this problem and immediately knew it was greedy, just from the words in the problem statement. I did not guess, I extracted the signals. The problem says flowers cannot be planted in adjacent plots. Okay, that phrase adjacent plot tell me we are making a decision at each position independently. We are not looking at the whole array once. That signal 1, local decision making. And then it says without violating the no adjacent flowers rule. That means if I plant at position 2, it only affects position 1 and position 3. Nothing beyond that changes. My local choice has only local consequences. That signal 2. Local choice doesn't hurt future options. Finally, return true if n new flowers can be planted. So it's asking for a yes no answer, not an optimal arrangement. That means we don't need to explore multiple paths. Plant greedily, count, and answer. That's signal 3. No backtracking needed. Okay, so from the problem statement, adjacent plots violating the rule and can be planted true or false, right? This is basically three signals. Signal 1 is local decisions at each step. Signal 2 is local choice has local impact only. Signal 3 is no backtracking needed. All three signals, that means this is a greedy problem. That is a skill. Not memorizing that L605 is greedy, but reading any problem statement and extracting these signals in real time in an interview before writing a single line of code. That's what impresses the interviewers. Now that we know why it's greedy, let me show you the key insight. The entire solution collapses to one rule. If a plot is empty and both of its neighbors are empty or doesn't exist, plant a flower there immediately. Don't look ahead, don't calculate, just plant now. Okay. So the rule is basically, if flower bed of I is 0 and left is also 0 or out of bounds, okay, and right is equal to 0 or out of bounds, then in this case simply plant mark as 1, count minus minus, okay. Count minus minus. If a count reaches 0, return true immediately, otherwise scan the full array and return n less than or equals to 0. N less than or equal to 0. Now let's write the clean and interview ready code. So we have this function signature given on LeetCode. Okay, so the inputs are array of integer flower bed and then integer n. So we'll start by scanning from left to right. Okay, for that we will take the for loop I is equal to 0, I less than length of flower bed, then I plus plus. If the c- current plot is empty, then what we need to check is if the our left and right neighbors are empty. Okay, so let's write the first left neighbor empty condition. So when will be left neighbor will be empty? The first condition is if I is equal to 0. For example, let's say we are at the 0th position, so there is no left neighbor to it, right? So in that case we consider this as a empty. Or flower bed of I minus 1 is equal to 0, and let's write the right empty conditions. Okay, okay, so let's say we are at the last position. Okay, for example here let's say we are at the 4th position, so there is no right neighbor to it, right? So in that case we consider right neighbor as empty. So I is equal to let's say flower bed minus 1 or flower bed flower bed of I plus 1 is equal to 0, right? So if left and right both are empty, then what we will do is we simply plant the flower equal to 1. Okay, and then we simply reduce the n, and if n becomes 0, then that means we have planted all the flowers, so simply return true, no need to scan an entire array. Okay, so then there might be a case with where n is given uh, 0 since the start. Okay, so in that case we what we will do is we simply handle this condition using this n less than equal to 0 condition. Okay, so if n is 0 since the start, then whenever we find the left and right neighbors are empty, then we plant the flower and then we decrement the n. Okay, so in that case the n will become either negative or it will be less than 0. So this condition will handle the case where n was 0 to begin with. So now let's run this program. Okay, so we have taken the example from the LeetCode 10001 and the n we have taken is 1. Okay, so basically we can, so if is n is equal to 1, then we can plant the flower, right? we can plant the flower at the second index. So the answer is true. And let's say if we make it 2, and now let's the now right, if n is equal to 2, then the answer is false because we can't plant two new flowers in this uh, flower bed considering the no adjacent flower rule. Here is exactly how to frame this in an interview. So this is your interview script. Memorize the structure. I recognize this as a grade A problem because we are making local decisions that don't affect future opportunities negatively. I scan left to right and plant at every valid position where the current plot and both neighbors are empty or out of bounds. I decrement n each time I plant and return true if n is 0. Time complexity is order of n, space complexity is order of 1 because I modify in place. Okay. Approach, condition, complexity. That's the structure every time. Let's cover edge cases quickly. 4 worth mentioning in an interview. If n is 0, always return true. Trivially satisfied, no planting needed. Single plot and that is empty and n is equal to 1, return true. No neighbors always valid. If all plots are empty, fits that basically fits 3 flowers at position 0 to 4. Okay. Already full with n is equal to 0, simply return true. Final return n less than or equal to 0 handles this cleanly. One condition covers all of this, no special casing needed. Quick complexity before we close. Time complexity is order of n. Single pass through the array. Space complexity is order of n. We modify the flower bed in place. No extra memory needed. Can we do it better? No. We must check every plot at least once. This is already optimal. Now let's wrap up. This problem tests one specific skill. Can you identify when greedy is the right tool? Not every problem needs dynamic programming. Not every problem needs a complex data structure. Sometimes scan left to right, take the best option at each step, and trust that it works. That's greedy thinking. And knowing when to apply it is what separates good engineers from great ones in an interview. Practice explaining this out loud. Drop your explanations in comments. 30 seconds. Let's see if you got it. See you in the next one. If you are preparing for coding interviews, this is the LeetCode 75 series where we solve every problem with full intuition and go code. Click the playlist on screen and continue with the next problem.